Quantum physics, also known as quantum mechanics, is the branch of physics that studies matter and energy at the most fundamental level. It seeks to understand the properties and behaviors of the basic building blocks of nature. ScienceExchange.caltech.edu. Key principles of quantum physics. Wave-particle duality. Particles such as electrons exhibit both particle-like and wave-like properties. This means they can behave like discrete particles and also show interference patterns characteristic of waves. Energy.gov quantization. Certain physical properties, like energy, take on discrete values rather than a continuous range. For instance, electrons in an atom occupy specific energy levels and cannot exist in between these levels. Heisenberg's uncertainty principle. Formulated by Werner Heisenberg, this principle states that it's impossible to simultaneously know both the exact position and exact momentum of a particle. The more precisely one property is measured, the less precisely the other can be determined. Superposition. Particles can exist in multiple states simultaneously until they are measured or observed. For example, an electron can be in a superposition of being in multiple positions at once. Entanglement. This phenomenon occurs when particles become interconnected such that the state of one particle directly influences the state of another, no matter how far apart they are. Entanglement has been experimentally observed and is foundational for emerging technologies like quantum computing. Historical development. Quantum mechanics emerged in the early 20th century to explain phenomena that classical physics couldn't, such as black body radiation and the photoelectric effect. Pioneers like Max Planck, Albert Einstein, Niels Bohr, Werner Heisenberg, and Erwin Schrödinger developed the foundational principles and mathematical frameworks of quantum theory. Applications of quantum physics, electronics, semiconductors and transistors, which are essential components in modern electronic devices, operate based on quantum principles. Quantum computing. Quantum computers utilize principles like superposition and entanglement to perform computations far more complex than traditional computers. Companies like Google have developed quantum chips capable of solving problems in minutes that would take classical supercomputers millennia. Barons.com medical imaging. Techniques such as magnetic resonance imaging, MRI, rely on quantum mechanics to produce detailed images of the body's internal structures. Cryptography. Quantum cryptography aims to develop secure communication methods based on the principles of quantum mechanics, ensuring that any attempt at eavesdropping would be detectable. Challenges and interpretations. Quantum mechanics is known for its counterintuitive and abstract nature. Various interpretations attempt to explain its underlying reality, with the Copenhagen interpretation and the many worlds interpretation being among the most discussed. Despite its abstractness, quantum mechanics provides precise predictions and has been validated through numerous experiments.